All right, so good morning one more time, and welcome to Computer Science 3A. This is our very first lecture. So we'll be going through the learning guide for the module, covering what you can expect for this module, and then timeline, we will get started with the first lecture. I have a question regarding the low audio output. As far as I can see on Blackboard here, it's pretty well received, so you'll have to try and adjust that on your side.
It is a
Right.
little,
It's a little low. All right. I'm not even sure how I could adjust that over here, but I will try if you give me a moment. Then perhaps, Prof. Vandahari, would you get started while I try to fix that?
yeah, sure. Welcome everyone to your first lecture for computer science, as Mr. Malaleka has mentioned. Um, just a few things with regards to the module itself. While Mr. Malaleka sets up, I'll just to explain the first parts. So there's two lectures for this module. The first one being Mr. Maluleka. He will be taking up the first half of the semester, and I, of course, will be taking up the second half. Um, we also want to mention that this particular module, as you can see, it's called Advanced Data Structures, is all about a lot of the fundamental aspects that are required for solving a little bit more complex problems. There is no guest link for the session. Everyone that's registered must join through the app under. So there's a lot of things that we're not allowed to do like that. There's a lot of reasons for that because we can actually see who joins, who attends class, and all that sort of stuff. And giving out guest links is a bad idea because of that reason. So, as I mentioned before, if you want to solve a lot more complex problems, you want to be able to have a lot more advanced tools. Now, in this case, that's what this module is all about. Um, Essentially, learning about the newer tools on top of what you've already learned in order to solve for more complex problems. So, if you've got a little bit more complex problems, naturally, if you remember, you would still have some form of abstraction where you're taking a complex system, distilling it into its subcomponents, and solving for those subcomponents. So that's still there. And you'll see that abstraction is a wonderful, wonderful, wonderful thing. And what's really, really nice is that the flexibility of building software is there's many ways to do it. And of course, because there's many ways to do it, there's naturally a good way to do it and a bad way to do it. And we're going to focus more on how to do it the right way or the good way, where it's computationally more efficient. So there's a lot of themes you'll see that we revisit from the past 2 years that are very important in that regard as well. So we we try to explore the following learning outcomes. The first one being that we're gonna, as I said before, revisit some stuff, and part of the stuff we revisit is data structures. So a lot of the theoretical stuff related to that, the usual stuff like you've learned from first year, like arrays, singly linked lists, doubly linked lists, uh, you know, array lists, the stuff that's relevant for all of that. And what you'll see is we'll move from linear data structures and some of the linear data structures, like I've mentioned before, to more nonlinear data structures like trees and all their variations thereof. And what you'll see is that object-oriented programming has a role to play in these data structures as well, which you already remember from Computer Science 2 with design patterns and all that. And if you remember from first year and in fact second year, there's also big O notation and uh, determining the computational efficiency of certain um, tasks and things like that, and the assessing whether the performance of those algorithms are good or bad is part of that. And of course, the usual, you can actually implement, and that's naturally what you want to do. You must be able to implement, and you know, when it comes to the implementation, you want to make sure that you cover your bases for, I want to say, some of the newer stuff. Now, I know a lot of the every year you forget about what happens. At first year level, you forget everything. Second year, you forget everything. So, what I want to say is try not to forget everything. And, we are revisiting a lot of it. A good chunk of the year, sorry, the semester, is just that. Some of the module resources, the usual stuff include, um, you can see uh, obviously the lectures that we've got there. There'll be a live lecture. By the way, it's not on YouTube. It's all on Blackboard Collaborate. I know some people are asking where's the YouTube link and stuff like that. It's just a typo in there. This semester, we're only doing Blackboard Collaborate, and the practical assignments work slightly different this year. Um, And one of the things that we want to do is actually uh, get you used to getting a problem and then solving in a shorter period of time. So you don't get the whole week to do the practical. It's the idea behind it is you get the problem and then in the same day you submit your particular assignment. So, just before I get to your question, some of the things that you should be aware of is you always want to make sure that you consult Eve, the notices especially. Make sure that you also get some help from please do join the Discord channel. It's very important. You'll get a lot of support there, and don't be afraid to ask questions and all that. There are some ground rules like, and I'm sure Mr. Malulek will explain some of the ground rules when we get to Thursday. Let's answer some questions. Is revisiting some content going to help us complete the mini project? The mini project this semester or this year is all about blockchains. Now, you'll see that it's using a graph to implement for a blockchain. Now, what you'll see is that the data structure itself of a graph is something that's not unfamiliar. If you remember from computer science 2B, you have nodes and edges for the different nodes that communicate with one another, especially when you do the shortest path calculations and stuff like that. And what we're essentially doing is a graph like that. That by the way, that is a graph. And what we're going to do is we're going to essentially uh, use that graph to build a blockchain. Now, blockchain, if you go read your mini project, and I'll be giving some extra resources on blockchains and all that, as we progress through the semester. But a blockchain is essentially a a collection of transactions, where in this collection of transactions, there's a fundamental link from this block of transactions or records with the previous block. And there's some sort of way of determining the validity of the previous block because you use a cryptographic hash to determine if a block is valid or not. Now, that's a very high level description. And, this high level description is actually enough for you to go and look at what's blockchain's all about. So obviously the mini project and all that is about blockchains, and we'll talk a lot about blockchains as we progress throughout the semester. But I would, if you're unfamiliar with blockchains, I would definitely go read up about it because mini project is the semester project. So it's supposed to take a long time to do that, and it does require some detail from every bit of the way. So there's a lot of self-learning involved as well. Is it a big problem uh, if we only use the sixth edition rather than the international student version? No, it's not a very big problem. There's quite a bit of similarity there. And yes, the recordings, of course, will be available on Blackboard. So can we please get the link for the Discord server? Yeah, sure. We can definitely do that now in the chat if you want. Um, any other questions so far before we begin? Thank you. Will practicals be conducted on campus? The short answer to that is no. There are some resources that you can go, some labs and everything that you can go to specifically go and do the practical on campus. And because everything, all the resources are there, everything still will fundamentally be virtual. I just want to stress that. Everything will be virtual. All the practicals will be in Java. Are you ready, Mr. Maleka? Still struggling?
Yes, I've switched to my headset properly, so I hope that's a bit louder. We'll be developing our practicals in Eclipse. Yes, you'll be using Eclipse as the IDE.
It went louder and then softer for a bit.
Okay, I'll try to speak up. There's not much more I can do with that right now.
Okay, well, you don't have to use Eclipse. You can use any IDE as long the programming language is in Java. You all grown up, you know how to program in Java and all that. You can use whatever preferred IDE, even if it's Notepad or Notepad++ or any other variations.
Okay, but when I'm doing demonstrations in the practical lecture, I will be using Eclipse, and your project should be able to be imported and run in Eclipse as well. So as Prof. Andahar mentioned, the two lecturers for this module are myself and Prof. Andahar. We do have consultation hours, although those will not be on campus. Those will be on Discord. So there is a consultation voice channel, and will be available in that channel on the time stated here. Prof. Andahar on Tuesdays 2 to 3, and myself on Wednesdays 11 to 12. Okay, it seems people are still struggling to hear.
It's going up and down.
Okay. Give me a moment,
It's fine. I'll keep going until you sort out.
Yeah.
So, as Mr. Maleka mentioned, if you didn't hear that, we each have our own consultation hours. On Tuesday at 2 o'clock to 3, that's mine. Of course, this is all virtual, so please use Discord during that. And you can, of course, what we like to do sometimes, and I know that it's quite a pain to talk and all that, you just join one of the voice channels for the consultation, and then you can talk rather than type if you prefer. But a lot of people also prefer typing out. That's okay too. Mr. Malileka's hours is on Wednesday from 11 to 12, and specifically for these particular consultation hours, naturally, there's also there's a tutor allocated in the lab. Now you'll just need to, of course, join the virtual computer lab. With regards to the virtual assistance lab for this particular one, I can also get the I'll see if I can post the link for that as well. It should be on the general Eve uh, you know, announcements. You'll see it on the news there. So please do, if you need any help with, understanding some of the stuff. Now, what this is all about is making sure that you understand what's happening. If you do fall behind for a practical, and of course, if you're falling behind in, the first handful of practicals, it's going to be quite problematic because remember, as I said before, we're revisiting part of the older data structures. But of course, the only difference is some of the, because you're doing it in Java, things are a little bit different. Will we be given extra practical questions that will help us prepare for the in-session practicals? We always give you the topic in terms of what the particular practical will be about to prepare. So um, in terms of extra practical questions, not that I'm aware of, but you'll see that you get the topic that this practical is all about, and of course, you know, today we'll cover that, and then you'll be able to prepare until Thursday, where you'll be able to do this. Now, um, in this particular example, when you have your practical, you must be able to prepare, and I can't stress this enough. I know a lot of you are freaked out that you're going to get in-session practicals and you need to be done and all that, and there's a lot of complications, and we've extended. We'll explain on the day of the practicals how it's going to work, and you'll see that the first practical is normally very nice and friendly. There's no complicated parts to it, and you know what you want to do is you want to make sure that you get your environment set up and you're good to go in terms of once you receive your practical, when it gets released, you'll be able to complete it in time. So next question is, are we going to have Saturday classes? The short answer is no. Uh, it's not like some of the previous years where you have the Saturday classes, and it's all about being in third year. You need to have a lot more self-discipline, prepare, and please do leverage the Discord channel and email and all that. You'll see that we're very willing to answer any questions and all that. With of course within reason. I'm not going to respond to you at 2 o'clock in the morning or on Sunday or anything like that. Or and the idea behind it is that you'll see that it's a lot more flexible to ask questions, and that's one of the best things about all these virtual classes is the access. Now, I know a lot of you are sometimes shy to just walk into the office, but it's a lot less painful to send a message over Discord. So please do bug us. Will the first practical start on Thursday? Yes, the first practical will be on Thursday. We're already short on time when it comes to the semester, so we'll immediately start. And of course, as I mentioned before, it's like a dry run, so it'll be a nice, simple practical for this week. You want to comment on that, Mr. Maluleka? I think it's still, yeah, it's still sitting out. I'll answer some more questions. Sure. Does the Discord have screen sharing? Yeah, definitely. If you're joining, for example, a voice channel, you can share your screen. We can even go through parts of it, and there's all sorts of stuff. And I think a lot of it is just you must go play around, go see. There's a lot of cool things you can do. Like I can share my screen, you can show your screen, all sorts of stuff like that, and I can comment on specific things that help out, and it's just a matter of understanding how you can help yourself, right? So once you've got everything you need to do for that, then it works out just fine. And I want to say that normally email is very asynchronous, but of course with instant messaging using Discord and all that, it becomes quite handy. So I'll carry on while Mr. Malek is trying to get his sound right. So the first 7 weeks, as officially mentioned by the university, is completely online. So what this means is that there are no physical on-campus classes and practicals. And I mentioned that the practicals, you can go in on campus and do the practical on campus if you're having problems and all that. Just please be safe, and of course follow social distancing and make sure that everything is okay. So Tuesdays, 8 o'clock to 9:35, like in the session right now. Please make sure that you log in. There's not going to be any guest links as I've mentioned before. The other second class, this one of course is the longer one. The second one, the shorter one, is Wednesdays from 12:10 to 12:55. Again, all using Blackboard Collaborate Ultra. And the practical starts off with a practical lecture at 1 o'clock, and you know we sort of give some background. Sometimes we go through the previous practical to make sure that you understand what exactly is happening, and then of course you know you can ask questions related to the practical. And the session officially ends at 5 p.m. But there will be some wiggle room with regards to submission of practicals, and as I said before, we'll explain more in the practical session. Don't freak out too much about all this, and all I ask from you is to prepare for the practicals. Install your environment, make sure that you've got your preferred IDE. You've got your usual stuff set up. You still remember what arrays and other stuff are, the basics, and you should be good to go. As mentioned before, any clashes and all that must be brought to attention. Now, I've checked myself, and there are no clashes, especially for this group. There's some minor stuff here and there that are technically not a valid clash. So, but because things are online, it makes things a little bit easier. So, but I'm more specifically referring to things like semester tests and exams and all that. If you see something, please do let me know. I have checked, but there shouldn't be any problems in that regard. Mr. Monica, are you okay there? Okay. So how the semester is arranged is in the following way. Now, of course, today's lecture is in this week's all about the introduction, so the basics, revisiting the usual aspects, like you'll see in the lecture now. We make sure that everything is all fine in terms of reminding you of everything you may or may not have forgotten, from the previous years. Then as I said before, we start off nice and slow. So we do arrays, linked lists, recursion, the basics. Then, of course, we do analysis tools and algorithm analysis and a big O notation with a slightly newer stuff that you may have not known about, like big theta and big omega and things like that. But in all the fundamental functions that describe optimization, or when you're describing the computation complexity of a particular solution, you can analyze it, of course, in various different ways. We then move on to stacks and queues, which you should all be familiar with. And we then touch on lists and iterators, and also which you should be familiar with. And then we start with our first sort of bit of new stuff, like in this case, trees. Now, technically, a tree is a graph. Now, people are freaking out already. What is a graph? What do you mean? And you spoke about the shortest path and there's nodes and edges. The short answer is a graph is a unstructured sort of abstract data type where there's some nodes and edges, and you can add nodes or add edges, and you can of course traverse it. You can move on the graph itself. A tree is a little bit more structured, where it has a root, and then you can branch out to many different branches. You should all know what a tree looks like. Hopefully, you've at least passed one tree in your life, and hopefully, there's many trees that you've seen. It's really sad if you haven't seen a lot of trees, but just like normal trees outside, there's some sort of root, and there's a and there's branches from there. And you're probably wondering why we talking about trees in computer science. Is that this trees are one of the nonlinear data structures. Now, when you hear the word nonlinear, don't freak out. It just means we like a linear data structure where we either going backwards and forwards, and that's the options in the table. There's a little bit more options than how you can move down the first branch, down the second branch, or in graphs going from one node to another node in some traversal manner. So just before the recess, we cover priority queues, which of course is not. It's just a variation of a queue, just with a priority baked in. Then we have the recess, and after the recess, this is where I would normally take over, and we cover maps and hash tables first. So maps are quite cool, um, and hash tables are also very computationally efficient, but they come at the cost of lots and lots of memory. And then there's dictionaries and skip lists, and then we cover all the wonderful search trees like AVL trees, 2-for trees. Then we do red-black trees and all the other wonderful trees that you may or may not be familiar with before we cover the remaining parts of where we cover graphs and everything that graphs have to do before we hit revision. We'll be continuing with network programming even now we're in the second semester. The short answer is for your mini project, there's actually a data communications component. So for a blockchain, because you're essentially going to be creating an application that can communicate with other nodes and all that sort of stuff, right? And you want to make sure that it is a distributed client. So in other words, one client can connect to many, many other clients on a peer-to-peer basis. And the network programming part for that is the only component in this semester that will involve networking or data communications. Next semester, that's the same. Yes, you'll understand the fundamentals because you're doing operating systems and how that works, and finding out how the hardware relates to the software and all that. But beyond that, there's not much data comms left to do. If that's a happy thing or a unhappy thing. Is there a reason why you're asking about data communications? Smiley face or sad face? All right, so uh, the assessments for the semester is all about this. It's nice and easy to calculate your semester mark. It's pretty much there's 4 quarters. The first one is your first semester test. Second one is the second semester test. Then all the class tests and practical tests are also 25%, and your mini project is the last remaining 25%. So you'll see that specifically the mini project and the semester tests are a good significant portion of the semester. So your practical component mark is calculated using the bottom 2 parts, the class test and the practical tests of the practicals, as well as the practical mini projects. There's no practical test, don't freak out. So the class tests you'll see will happen all throughout. It's going to be virtual tests. It'll be a mix of things like Blackboard stuff and all that. I don't know, Mr. Malaleka, how you're going to be doing your class tests?
Yeah, so they'll be uploaded on Eve and facilitate. Oh no, the class tests. Well, actually, this year I would like to try and use Blackboard. They have some functionality for MCQ tests, so you may try that. Um, and remember that every lecture that we have or practical is an opportunity for a class test, so you may have one during a practical lecture as well.
Yeah, it's much, much better. You want to continue?
Great. Yes, sure. All right, so I missed some of it, but I believe we're at the section where we're talking about assessments, and Prof. van der Haar just described how your semester mark is calculated. And of course, once you have that, that counts 50% of your final mark together with your exam mark, which counts 50%. So the semester dates have already been set. The first one will be on the 25th of March at 2 o'clock, and the second on the 20th of May at 2 o'clock. Please note that if you're going to, in the unfortunate event that you have to write an SSA, you have a week after the initial assessment to submit your application, and the dates for the SSA assessments have been put there as well. A note to those of you who like to write SSAs, looking at the throughput, the SSAs always have a much lower throughput than the main assessment. So do yourself a favor and make sure that you write the main assessment rather than counting on those SSAs. And also those tend to clash with other assessments for other modules as well, whereas the main assessments have been checked and there are no clashes regarding those. Both test theory, yes, both tests are theory tests. So practical assignments, each week we will have a practical assignment. We will have a lecture here on Blackboard where we discuss the assignment. They'll then be released on Eve. I'll be available on Discord for the duration of the practical session to facilitate. You may ask questions. We encourage you to discuss the issues of the assignment, but you're not allowed to share any code. That means not sharing any code with each other on Discord or through any other means. Please note that we do run your practical assignments through a plagiarism detector. So even though it may seem that you've done well in one, if we pick up later on that you have copied code from someone else, and that mark will be changed to a 0. The final assessment will be a 3-hour exam, and the date for that actually is available on the university schedule, and we'll add that to this. All right, so that is the very end of that. Prof. Anant, is there anything else you want to add?
Sorry, I just want to add, I see there's a question there for, will the semester test be written online or on campus? They'll be completely online. So what that means is, just like you've been doing with computer science 2B and all that, where the semester test will be uploaded on Eve, and of course there will be some support via Discord, and you'll be able to write it and submit it and everything. I just want to mention as well, there's also some checks done during the semester tests and all that you may or may not know. And of course, every one of these tests and submissions are analyzed, and all sorts of other weird and wonderful things to prevent any problems from occurring. So please don't do something silly. Just to put into perspective, there were quite a number of people that were expelled, last year because they tried to take chances and all that. And it's really, really horrible to be expelled in your final year because you don't get your degree, and it's a permanent record. It's on your permanent record. So every single time someone requests your academic record from the university, it's there. And the question you need to ask yourself is, if you get something on someone else's academic record that says that, would you hire that person? And please, please, please don't be silly. Don't cheat or plagiarize on the practical assignments, and of course the semester tests. If everything's on, written in your own words and all that, whether your choice is to type it out or write it out, please do it on your own. And don't try and see if you can fool the system and all that. There's a lot of people that have been expelled who tried. So that's all I wanted to say on that. Thank you.
All right, thanks, Prof. So just to reiterate, at least for the first 7 weeks, everything will be online. So our classes, practical sessions, assessments, everything will be online, and it's likely that that will continue into the next term, but we'll discuss that as the situation goes ahead. But the first 7 weeks are definitely going to be online. So you'll see that on Eve, we've already uploaded the mini project description and mark sheet there. So for your mini project, you are required to create your own application that will demonstrate your proficiency in a particular data structure. or rather in the data structures that we cover in this module, and especially the graph ADT. So as Prof has explained, you guys have already used graphs previously, even if you did not study them explicitly. And you'll be expected to do some self-study to be able to get started on your mini project as soon as possible, because you'll only be covering graphs in the module in the later half of the second term, so that'll be way too late. We will make some open educational resources available to you to help you get started, but most of it will be self-study. All right, please note the deadlines for the mini project because there'll be no exceptions, and late submissions will suffer a penalty, but even that up to a point, after which we will not accept any late submissions. So there's some rules that we have to stick to. You have to use Java. As Prof said, you can use whatever IDE you wish. Your submission should be in a single zip file, and it has to be executable, but we'll mention that later. There's a file name convention that you have to adhere to, which is student number underscore mini project zip, and that zip must contain all your source files for us to be able to compile your project, and executable file for us to be able to run that project. So within it, you should have 3 directories: your source directory that contains all your source files, your distribution one disk that will contain your executable jar file, and SS, which will contain your PowerPoint presentation that you have to submit as part of your project. We will discuss it a little later, but you can also, for additional marks, submit a video where you explain your project and actually demonstrate its use. You are allowed to use, or rather, we should state, although you are allowed to use things like JavaFX and other libraries that are part of Java or are now actually additions to that, the primary functionality of your application must be implemented by you. And within that, you're not really allowed to use, or the core part of your application should be your own code, but you are allowed to use some Java libraries for input and output and visualization, like JavaFX. So your assignment must be in a executable. You must also include an executable jar file so we can execute it. And if you don't, then you won't get any marks for it. All right, if your assignment is too big to upload onto Eve, then you'll simply be submitting your source files onto Eve, and we'll make alternative methods available for you to be able to submit your entire project. The assignment must make use of a graph-based structure at its core. Though you are allowed to use additional data structures, all of which we'll cover in the module, but these should be for auxiliary operations, not the main core of your project. You must implement the data structures you use yourself. However, for the graph, we will give you an implementation of that. But if you're going to use auxiliary data structures, then those should be implemented by yourself. Obviously, you may not implement a practical that we've already given you, practical assignments you've done in the course of this module, but we won't be doing one on blockchain, so that won't be an issue. And please note that this is an individual practical assignment or project assignment, so you're not allowed to collaborate with any other students in any way. You're not allowed to make use of any internet sources. It must be your own work, and you must implement it yourself. So the theme for this year is blockchain with graphs. So you have to implement a blockchain-based application using a graph as your core data structure. So blockchain is a collection of records called blocks, where each block links to a previous block using cryptography. And each block contains a cryptographic hash, timestamp, and data relevant to its application. So you can think of it as a distributed ledger, where instead of information being stored in a database or in some central trusted repository, it's stored on this blockchain. All right. There was a question about whether the weekly practicals will actually assist you to get started with your project. Now, as I said, there will be a significant amount of self-study for you to be able to do this. However, I am going to work cryptography into the first few practical assignments, and specifically using some simpler versions of the type of data structures that you will find within the blockchain. So that will kind of help you understand what's going on, even though it won't be the exact same thing. All right, I have a question. In that 25% of practical and class tests, so they weekly pracs in 10.2%. All right, the breakdown is exactly as it's given in the learning guide. That only gets scaled down when you then take that as 50% of your final mark. But the proportions within that distribution are as given there in the learning guide. So some examples of solutions that use blockchain at its core are cryptocurrencies. All right, that's the big one. Smart contracts, trading, supply chain management, anti-counterfeiting, healthcare, domain names, proof of existence, voting, and many others. All right. So while we have Prof. Nahar with us, are there any questions regarding the mini project?
Just to answer that question about the 25%, so are you asking what is the percentage of class tests and practicals and all that? How we calculate it normally is uh, we take the best certain amount of practicals and then we add on your best 2 class tests or best 3 class tests. Can take all of those together, and that's what forms your 25% of your practical mark for all your practicals. But please feel free to ask some questions about the mini project while I'm here. Okay, first question: what resources will be given to complete the mini project? Um, we're quite nice, so we're going to give you an actual graph, the graph ADT itself, the source file that actually is used to create the blockchain. I'll be giving that to you, so you don't have to implement that part. So you're not really going to be. So you get the source file for that. You just have to use it to create the blockchain. That's the idea. That makes sense? Uh, what characteristics do you need to possess to do well in this course? I would say you'll see that you need to understand the concepts, and I would definitely uh, recommend that the concept is coming in the week itself, and you say, okay, we're going to be doing AVL trees today. Go and try and implement an AVL tree before the practical happens. If you can do something like that really well, and you're strong practically for this, you'll see that you would do well. Understanding is one of the core things that I would say is quite important. Someone asks, almost like an API. No, you're actually creating an application. You are creating a. So think about it this way. Uh, if you have a BitTorrent client, right? You can do things on that client. It interacts with a whole bunch of other things under the hood and everything like that. So there's a type of application that you have that does all of that. And by the way, when it comes to how torrents work and all that, it's actually a variation of blockchain. I don't know if you know this. So how things get indexed and trackers, and there's blocks that are split up and all that. The only difference is there's no vetting scheme like they would have for a block and all that. It's like a scaled back version of that. And what we're expecting from you is to create some sort of application that says, okay, great. Let me pick one. Smart contracts. So, for example, smart contracts are a way of negotiating. So you have let's say, Checkers wants to buy some wine now that the lockdown's done. So let's say they negotiate with the wine farm. Now, traditionally, there's a middle party involved. So the wine farm would contact the middle party and say, okay, I've got 1,000 boxes of this particular type of wine, and I'm willing to, the middle party will say, how much are you willing to give and all that. And then checkers will go in and say, okay, can you negotiate us a good price? Great stuff. We'll buy it for that amount. Now, smart contracts are really cool. They negotiate automatically. You don't need the middleman. It is the middleman. So what will happen then is checkers will say, I will give you for the first 100 bottles, this is the price. Second 100 bottles, this is the price. And then checkers will say, okay, great. Let me put forward an offer, and I say, okay, if I buy 100, how much will you give me? If I buy 200, how much will you give me? And it'll automatically say, this is your price based on some prescribed rule base. So you would say, the reason why it's called a smart contract is that you're trying to negotiate terms between two parties in a dynamic way without a middle party. And how it works is you can then go back and forth, and then once the contract is finalized, you can actually put it in the distributed ledger that says, this is the rate that I gave that person between this one and that one. And, historically, you then can go and say, hey, but why did you give me 100 Rand a bottle last time and now it's 200 Rand a bottle? What happened? Or you can do things like using historical data to say, okay, we see that you bought lots from us, you get a better price. So that's the idea. So an idea is the checkers would then have the application, and then the wine farmer with the application. And the idea behind it is not some message, and it's not a message just back and forth. It's actually, this is the rules. This is my cutoff point. I specify a nice little schema of sorts, and I say, okay, I'm willing to buy this much. This is the price I'm going to do. And then the other side will go, this is what I want to do. I don't want to go any lower than this and all that. And they put it in, and then the thing does its thing, and then bam, it pops out. Someone's buying wine today. Make sense? Okay, let me answer some more questions while you think about that. Will the use of JavaFX or some UI component be necessary? Or is it alright for the component? No, it's not alright to run in the console. You must use some GUI. It doesn't matter which GUI you use. There must be something that you can interface with. So, like I said, you must, as a user, be able to interface with the system, and you'll be able to do that. So, running entirely from the console is not okay. You will see that in the next slide. You will actually see the breakdown. There's marks specifically allocated for that as well. When do we get that source file? Hopefully, it'll be during the course of the week. I want to say worst case by Friday, but we'll see how it goes. I can promise that by next week Tuesday it will be out. So I will be putting it up. So please don't freak out, and I'll try and make sure that you have more than enough time to do your mini project. Are we intended to solve a problem like with regular practicals on our mini project? The idea is you want to solve a problem. So that's essentially what you're doing. You can choose the problem. That's the nice part about it. So there's quite a few examples that I've listed there. We've listed things like smart contracts and voting and all sorts of other things. But there are many ways, in principle, you could actually take any application and make it, blockchain if it's compatible. In terms of everything that you put forward, it will be visible to everyone because it's a distributed ledger. Then you can adjust visibility and all that sort of thing. So, yes, ideally you would be solving a problem. Are there any books that you can recommend to read about blockchain? There's quite a few resources. I know a lot of you don't like reading books. There's quite a few nice resources on YouTube, funny enough, that explain how blockchains work quite nicely. And what I want to say is that, just keep in mind, I'll see if I can find the simple one that I wanted to highlight. I'll put it in the chat right now. And it's a nice little simple description of how the blockchain works. And it breaks it down. It's a nice 5-minute video, and it's got all the components required to that. And you'll see there's a follow-up video for how they can actually be used. And that's the video I'm pasting right now. So if you read the one that I've read there, or the one that I've just listed right now, that should be enough to get you going for what's next. What does confirm the individual project by too much mean in the mark sheet? So each of you will be putting forward a little. You're going to be submitting on a Google form what you want to do with your blockchain. It's just a screen for any potential problematic issues, so you don't spend the whole semester doing something that is probably not a good idea. So to get some clarity and all that, the idea behind it is that you put forward what your idea is, what's your solution going to be in a YouTube form, and of course we'll be putting up the Google form, and of course you need to just submit your idea by the 2nd of March, and you get marks for that as well. So when will we know enough to do the whole project? Like how many new things we should learn before studying? Well, you should actually know enough now. If you go watch the videos and all that, and you go actually get the parts. Remember, this is a self-study mini project. It's supposed to be something that you work on throughout the course of the semester. And the idea behind it is when you actually go and look up. I'm going to be uploading the graph lecture notes and all that as well. You can go read up on the graph, what is a graph and all that stuff as well, and go look at what the blockchain resources. I'm going to be doing a video describing a more concrete example and all that that you can use, and we can definitely do that as well. So if an idea is rejected, will we be provided with one? The short answer is you could adjust your idea accordingly, but there is this, you can obviously modify it slightly to. You can ask us over Discord to why it is in particular rejected and what went wrong. So, for example, if you're going to put forward a cryptocurrency, obviously it's an automatic reject. That's the one thing you can't do. Um, so we're not allowed to. You're not allowed to do a cryptocurrency because there's an enormous amount of resources related to that. And I just thought you can get more creative with regards to some of the examples you can do. So basically, making a decentralized application. Yes, it's a decentralized application, but it uses a blockchain under the hood. That's essentially what it is. You're correct. Any other questions? Is Thursday's practical difficult? I don't know. What do you think, Mr. Maleleka? Is it difficult?
Well, we haven't covered anything yet, so it shouldn't be difficult, should it? No, you're going to be using data structures that you've been using before. We'll give you a problem to work with. You have to use that data structure to store data in and do some operations on it. It won't be something difficult. But then, of course, that assumes that you know all the work that you covered in CompSci last year. So it may be a wake-up call for some of you, but if you remember that work, then it won't be difficult.
Are we allowed to use crypto libraries, something like AES for me? But yes, that's perfectly fine to use. For if you want to do encryption and all the hashing and all that, you don't have to physically implement it if you want to. You could use some libraries for that part for calculating. But you'll see that Mr. Maluleka is going to show you how to do all sorts of wonderful things, in that regard. So the other thing I also want to mention is that, let's take a few moments past and say one day when you start looking out for a job and all that, and they ask you questions with regards to software development, uh, you know, funny enough, a lot of the questions they ask is actually from Computer Science 3A. So a lot of people study for this particular subject because that's the technical interview questions you would typically get. So it's probably a good idea to to sort of get used to these types of practicals and all that because it's going to come throughout for the rest of your life as well. The only difference is you're going to prove that you are amazing or not amazing in that technical interview. Are they going to be lead code kind of problems? What's a lead code kind of problem? The really difficult ones. But lead code is cool though. Do you want to answer that, Mr. Mullen?
Well, I do sometimes look at programming competitions for inspiration, but given our time limit, it's usually a watered down version of those types of problems. And what topics should we revise for this week's practical? All right, I'll give it away. It's going to be operations on arrays, but not necessarily one-dimensional arrays.
Okay, just to wrap up the mini project, please, you also look at, I'll repeat again, you can't do a cryptocurrency and it's not a utility library. There must be a front-facing part to it, and it can't be plagiarized. As I mentioned before, there's going to be a Google form that we put forward on the notice board as well as on Discord to confirm your project that's due on the 2nd of March, just to weed out any problematic ideas and all that. If you follow the brief and all that, everything will be fine, and you wouldn't have to worry too much. We've disclosed the mark allocation right up front, so there's no you know uncertainty with regards to how this will be assessed. Of course, 15 marks for abstraction, in other words, translating the problem domain into the specific blockchain based solution. The use of a graph-based blockchain, taking the source file that I've provided and creating a blockchain out of it. Of course, that you get marks for that. Logic and complexity, it follows a dynamic graph. It facilitates the solution really well, and it does what it needs to do, what you set out to do in the first place. There's explicit marks allocated to the graphical user interface, as you can see there. That's for 15 marks, and you'll see that there's also a good chunk of marks actually allocated for data communications. As I said before, this is going to be a distributed client that you're trying to deal with, so like a peer-to-peer client. Um, and you can use what you've learned last semester, and you can use some sort of other libraries like Nixio or variations and all that for the communication. It doesn't have to be manual communications. You must be able to communicate in some way. I'm not being explicit in terms of how I'm not expecting you to open up a socket, connect a socket, connect to a server socket, and do all the horrible communication and all that. What's really important is how you formulate the message and send it to the other side. That's relevant for your particular one so that it can be processed in some way in terms of the blockchain. Remember, that's the idea behind it. That's how you leverage this data communications to solve for that particular problem in there. And you'll see that there's explicit marks allocated for a video. This 8-minute video describing the project with a slideshow and all that. There's also going to be another resource video for how to do one of these with tips and tricks and all that. And that will be for 10 marks. And that's the mini project. Any questions? Any last questions or comments? All right, that's me. I hope you all have a wonderful first part of the semester, and you enjoy everything up until that point. And I guess I'll see you after the recess, and I'll probably see you for the semester test and all that other weird stuff. Now I'm confused regarding libraries. Why are you confused? Can you be more specific about that? So anything that's not primary functionality, you can use a library for. So what that means is if, let's say for argument's sake, it's input or output related, you can use a library for that. So let's say you want to get really daring and actually have, let's say you use Unity, or you have some sort of wonderful front end that has all sorts of other things. Let's say you do a game with that uses the blockchain for certain parts of it. Think crypto kitties or things like that, or where it's a lot more complex in terms of what the input or output looks like in terms of the visualization. That's perfectly fine as well. As I say, input output is normally not primary functionality related, and the other thing that you can use for is the cryptographic hashes and encryption. The rest of it is not okay for that. That's what I just described now. So input output and the cryptography stuff, you can use libraries for. The rest is not fair game. So there's an in-session practice Thursday.
Yes, there will be. We'll have an in-session prac every week that we're not writing a semester test without breaks.
Okay. As in, you create a jar file that's executable. So if you remember, in CompSci 2, you're creating jar files and actually making sure that it can work. So when you double-click on the jar file, it'll work, and it'll execute. In other words, a compiled, distributable version of your mini project.
All right, and I will cover how to generate Java docs and a jar file in the first prac.
Anything else? Okay. Enjoy the rest of your the lecture. I hope things go well, and I'll leave you in the very capable hands of Mr. Malaleka. Thank you.
Thank you very much, Prof. All right. So what JDK version can we use? Well, the latest Eclipse requires to use at least version 11. The size and scope of our practical assignments won't really necessitate using packages or modularization. So you can use any version as long as you have all your source files in the default package in your source directory, so you can import and execute it without issue. All right, but any specific questions regarding the prac and how that should be done will be covered in the first practical lecture that we're going to have on Thursday. As I said, I will cover some things that you should already know. Where can you find it? You can download Eclipse, and it includes that. All right, so we still have a good amount of time, so we'll get started on our first lecture. So we're going to discuss some of the theoretical and practical concepts regarding Java, which means that you should actually know most of these things. If you have an issue or a question, please just type into the chat and we'll address that. Though most of these things should be familiar to you already, I did actually take a look at your CompSci 2A slides and note that all of this has been covered before, but you may not remember it because it has been almost a year now since you've done most of these things. All right. So you will all remember that Java is an object-oriented programming language, which means that the work of our programs is done by objects. Right? And to create these objects, we have to design what is this essentially a blueprint of what each object should be like, and we call that a class. So that's a description of the properties and methods of our objects that will be of that class type. Right? So that means what attributes should each object have and what actions can it take. And that's usually describing the data that it stores. And those actions are methods that change that data stored within our class somehow. All right, class modifiers, these you should be familiar with. An abstract class is simply one that has an abstract method. So that means the method does not have an implementation, simply a signature. A lot of these, like final and public, also apply to our methods and our properties, but in slightly different ways. So it would be great to get some input here. What does it mean if we say that a class is final? Cannot be changed, values cannot be changed. Okay, I think you're thinking of properties there. So if we say that a variable is final, yes, that means that we can only initialize it at declaration and we can't change its value. Yes, there we go. Cannot have subclasses. So it cannot be subclassed. That's basically the final version of that class. You can't have a subtype of it. Can't be extended, exactly. If we say that a class is public, well, that's a simple one. That means that any other code can access that class. You can declare variables of that type. You can create instances of that type with no restrictions. Then an object, well, as we said, an object is then an instance of our class. So we have this description. When we actually create an instance of that, we call it an object. We use a special keyword, the new operator, to do this. It does a few special things when we call it. It actually assigns or allocates memory for that object. It then initializes all the attributes of that object to the standard initial value. So that would be 0 for all our intrinsics, except for a char, which would be an empty one, and our boolean, which would be false. And then it calls a constructor given the arguments that were passed to it, and that will usually give meaningful values to our attributes, our instance attributes, and then we'll return a reference to that object. Now, usually you do this as part of an assignment statement, or else you just lose that newly collected object that you've created, and since nothing is pointing to it, our garbage collector will get rid of it. So usually you would then store that in some variable of that class type. All right. We have a string, which is simply a sequence of characters. You should be familiar with that. It allows us to be able to do operations on sequences of characters, and also to be able to access any character in that sequence using an index. And the dot operator is what we use to be able to directly access the attributes of an object. Now, depending on how our class was declared, we may or may not be able to use that dot operator. If the class was a public class, then yes, we can go ahead and use a dot operator to access its attributes. If it wasn't, or rather if those attributes themselves were declared as non-public, then we may not be able to access them. All right, that depends on the variable modifiers that we used. And here again, you should be familiar with all of these. If we say that a variable is private, or we declare it as private, what does that mean? So what code can access that variable if it's private? It can't be seen by other classes, exactly that. So even classes within the same package or any other classes can't access it. Only code within that particular class can access those members. All right, good. Everybody seems to understand that, or at least those have given an answer, which is good. If we say that it's public, well, that's the opposite. Any code can create instance of that class and then use a dot notation to actually directly access in those variables within that object. Protected, what does that tell us? Setters and getters. Well, someone has said they're setters and getters. Yes, you can have private attributes, private variables, where you can't access them directly. But if you have public methods like setters and getters that allow you to change them in specific ways, then you can access them. All right, and for protected, we have some answers. Only inherited classes can get them, and same package Both of those are correct. Together, rather, those are correct. So subclasses and classes in the same package. So it's actually both of those are incorrect, but together they are correct. All right, so it's in the same package and subclasses. Then what about static? That's an interesting one because it actually means something a little different depending on whether we're talking about a variable or a method. All right, if we say that a variable is static, what does that mean? Only one instance. All right, that is true. Cannot be overridden. No, that would be if it was final. We often use static and final together with variables to create a constant. So that may be why you're thinking of that. The only one instance is in the right direction. So if we say that a variable is static, that means that it actually belongs to the entire class and not a specific instance of that class. So if we have a static variable, there's a single instance of it. And if we change the value of that particular variable, then it will change for all objects that can access, okay, I'll should all of them, it would change for all objects that can access that variable. So if you think about it, if we have a sum object that's declared as static, and I create two instances of that class, and I increment the sum by one using one object and increment it by one using the other object, if it had been initialized to 0, then its value would be 2 and not 1 and 1 for each instance. All right, it belongs to the entire class, only a single instance is created, and all those objects will actually be accessing the same instance, not their own instances of that variable. Final, well, someone already gave it away. That means that we can't overwrite, we can't change that value. We can actually only initialize it at creation, and after that, we can't change its value. All right. Then we have a special type called enums that allows us to be able to declare a series of constant values in a convenient way. So usually if you're representing something like the example that's given here, days of the week, you have only 7 options, Monday to Sunday. And so you wouldn't want to waste space by using an integer or a double. You try and use the least amount of space as possible. Perhaps you declare a byte, and you say that the different values of that byte, even though we have more options that we need, would represent the days of the week. However, whenever you're using those values, they wouldn't have a deeper meaning. This allows us to be able to use those constant names as the values. And in fact, even when we print out, we'll see that those names are displayed instead of whatever values are being used on the back end. So I can declare an enum here called day. It has 7 values, Monday to Sunday. And in fact, this isn't as good as it could be. In fact, this Monday to Sunday should be in all caps because these are constants. But that allows me to be able to set variables of type day, of the enum type, to those values, Monday to Sunday. And if I was to ask, well, what's the value of X, it would then give me simply that constant value that we've declared, not whatever value is being stored in the back end. So if I was to say print out X, it would give me Monday. All right, so someone's already asked, could you please repeat definition of enum? Well, it's a special type, so it is like a reference type, a class type, that allows you to define a set series of static constants that represent a finite set of things. And this is a good question. Is Monday at 0 or 1? This is a great thing. It does not matter. You should not think of that. Instead, you should think of the days of the week, Monday to Sunday. You're able to create variables of type day and able to store the values Monday to Sunday without actually worrying about what's being used in the back end. All right, so whilst you're giving answers, the whole point is that you don't have to worry about that. If instead you chose to do it yourself, you would perhaps create 7 different constants. So you define them or declare them as final and static. Each of them would be some number, either 0 to 6 or 1 to 7. But then you'd have to keep track of that somehow. And of course, within your code, it wouldn't be readily understandable what you're talking about or what today minus some other day gives us, right? So instead, by having these concepts where we don't have to worry about what's going on in the back end, we can think purely about Monday to Sunday. So you can convert the enum variable into a string name. Okay, no, it's not a string. So you see, we don't give those. They're not like string literals. We're not giving them in between double quotes. It's simply constant variable names that we're able to use to represent a finite series or a finite sequence of, or a finite set rather, of options. All right. Then method modifiers. These work pretty similarly to those for variables. If we say that one is private, then again, that means that only code within that class can access it. If it's public, any code can access it. If it's protected, only subclasses and classes within that package. If it's static, there's a single version of that method. It belongs, or rather a single instance of that method. It belongs to our entire class and not a specific instance of that class. Final, so this is a little different. What does it mean if we say that a method is final? Okay, and I will answer that last question after we answer this. Cannot be overridden. Yes, so unlike with a variable, we're saying we can't actually assign it a new value. Here we mean that in subclasses of this type, we can't overwrite and create a new implementation of that method. This is the final version of it. It cannot be overridden. All right, and then abstract simply means that we have a method signature, but no method body. There is no concrete implementation. And that means that because our class is an abstract method, it is an abstract class. So we cannot create instances of it, but we can create subclasses. However, however, those must then implement those particular methods. All right, so there's a question, do we need to know Java FX for weekly practicals? Yes, you should know Java FX. Yes, you can be asked to create GUIs for your weekly practicals. I will give you some time to relearn some of that, so the first couple of ones won't have that. All right, but later on, definitely we do ask you to create GUIs for your in-session practicals. All right, then method types. Now, often you'll hear Java methods referred to as functions, regardless of whether they return some value or not, because really in Java, you always have to declare what type of value is returned. However, if it's a procedure, as in it does not return anything, then we say that type is void. So we use a special keyword void to say that this particular method doesn't return anything, because we have to declare what type is returned by any function in Java. All right, we'll call that a procedure. Other language have literal differences between a procedure and a function, and you declare them using different keywords. So a function, do we actually remember what a function is from its very first definition that we learned? So we have here, wouldn't a constructor be a procedure then? Well, a constructor is a special type of method, right? It's one that's called when we use our new keyword, so it would not fall into either one of these. Right? It's used purely for giving significant values to our instance variables, and it can only be called when using that new keyword. So it doesn't fall under one of those. Although since it doesn't return a type, you could say that, but it's quite different from all the rest because you don't even declare any type that is returned, even void. Okay, so someone said here a procedure is a function that doesn't return a value. All right. But my question was, what is a function? Do you remember when you first learned a function? Must have been grade 7 or 8. Okay, no, you're thinking of a function as we're discussing them now, right? And even there, logical grouping of code would be a method. If it returns some value, then it would be a function. I'm talking about a mathematical function. Do we remember what the definition of that is? Okay, it can't have been that long ago, and you have been using Okay, here we have an answer. Input X and output Y, all right? Function takes an input and splits output. Fx is all that I remember. All right, all in the right vein. So the exact definition, I believe, is a function is a rule that to each input gives exactly one output. So you first dealt with them when you had spidergrams, and that have something like a ×2 as the function operation, and you would then have lines leading into that, and you put in numbers like 2, 4, 8, and it would spit out 4, 8, 16, right? So it's the same thing here. It's a rule that for each input gives us an output. Granted, we actually have to define what that rule is and decide what the output should be. Right. So it's something that does the same type of thing, but allows us to decide exactly what that operation should be. And of course, they can be a lot more complex than simply arithmetic operations. A constructor, we already answered that in the question that was asked during the discussion of functions and procedures. It's a special method. We call it using that new keyword. It then gives meaningful values to our instance variables. And it's called when we create a new object. The main method, well, that's another type of special method. For our class to be able to be run as a standalone program, we have to have a main method, right? We have to have a place where execution begins within our program. And so if you don't have a main method, you can't run that class as a standalone program. It does not mean that if it has a main method, it has to be run as a standalone program. You can call that class from another class, then the main method will not be run. You'll simply be able to create an instance and be able to work with their attributes and methods. But the one that you do call initially has to have a main method. So we have a question. Since doing Java and CompSci 3, we need to create or work on Android apps in future pracs. No, not within this module. We do have a mobile programming module, but that's in honors. All right, so any questions? We should be familiar with all of these concepts, and I've worked with them. I'll continue to do so. You'll note that whilst we use Java, this module can already be taught in any object-oriented language. We use Java because you guys spent a year learning Java. Please repeat main. So main is a special method, right, that you have to have for your class to be able to be run as a standalone program. Because your program has to start its execution somewhere, and that begins in Java with a main method. So if you don't have a main method, you can't actually run that class as a standalone program. However, just having a main method doesn't mean it has to be used as a standalone program. All right, sometimes we'll create main methods simply to do some testing and debugging of that class as well. We should. Every class should be tested. But then our main program will perhaps use some standalone controller class that simply has a main method that creates instances of the classes that we have created and calls its methods to get some work done. As we said in OOP language, the work is done by objects. So expressions, right? So in Java, expressions simply something that involves the use of literals, variables, operations that allow us to be able to calculate some values, and we'll usually assign the result of these expressions to some variable. So a literal is any specific value, whether it's a string literal where you're given an actual string. So for example, your name between quotes would be a string literal, or values of any basic type. So a number could represent, by default, would say it's an int, unless you add an L at the end, in which case it would be interpreted as a long. So any of those counts as a literal. And in fact, also our Boolean literals, true and false, are also literals. So these expressions can also involve operations. Any of your arithmetic operations you should know: addition, multiplication, subtraction, division, modulus, any of those. And also some that we often use when we're looking at loops, and those are incrementing and decrementing a value. We have here I minus minus, I plus plus, and plus plus I. So we understand that I minus minus will decrement the value of I. What is the difference between I plus plus and plus plus I? Pre and post increment, I plus plus operates and adds 1. So yes, it means it decides which value of I to use, and then either have already, well, the two options are I can use the current value of I, then increment it, that would be I plus plus, or I can first increment the value of I, then use that within my expression. So if we had I initialized to 0, I plus plus would be use 0 first, then increment it. So the next iteration would then use 1, but the first iteration uses 0. Plus plus I means increment I first, then use it. So my first value of I would then be 1, not 0. All right, so it depends which order you want to do it in, either using the current value, then incrementing, or first incrementing, then using that value. We have logical operators that allow us to be able to evaluate any of our intrinsic types. So we can compare two ints to see if one is larger than the other, equal to the other, less than or less than equal to the other. We can also compare, so we can compare any numbers that we have, whether it's an integer, a long, short, a byte, a double, or a float. But we can also compare characters, right? That comparison is done depending on the underlying code that's used. So if you're using ASCII code, then depending on whether that character comes before or after the other character, that tells us whether it's greater or less than. So A would be less than B because A comes before B in our ASCII code, so its value would be less than B's value. All right, if we're talking about two lowercase letters, B's value would be 1 more than A's value. This also allows us to be able to extend this to strings by comparing character for character. All right. Then bitwise operations, or rather bitwise operators. So Java defines operators that allow us to be able to work on numbers bitwise, to be able to, even though this number may be represented in decimal in base 10, we can actually do operations in it or on it as if it was in base 2. So if we had the number 5, which in base 2 would be what? 110, then we could shift that to the left or the right. If we were to shift it to the left, that would be 1100, which is what? 8 plus 4, 12. If we were to shift it to the right, then our 110 could become 11, which would give us 3. We can also do the complement of a number, and we can do some other operations. In fact, even our shift operations could be done with more than one bit. So we can use our bitwise operators to shift numbers several bits to the left or bits to the right. All right. Then operator precedence. I assume you all remember from high school at some point BODMAS that tells us the order in which operations should be executed. We have brackets or parentheses, so things within parentheses should be executed or evaluated before things outside of that. We have of, which represents raising to a power, that should be done next. Then division, multiplication, addition, and subtraction. All right, so we can use, or we should assume that same operator precedence when it comes to arithmetic expressions in Java. If we want something to be executed first or evaluated first, we should put parentheses around that and understand that after that, raising to a power will be taken, and then division and multiplication have the same precedence, and then addition and subtraction. But because addition, subtraction, and multiplication and division are associative, it doesn't really matter which order we take those in. All right. Then casting. This is sometimes contentious, but I'll get to that and be very clear about it. But within Java, we can do two types of casts, an explicit cast and an implicit cast. All right, so someone asks, so it's operations using bits. Yes, bitwise operations are, well, bitwise operations on numbers. So casting can either be explicit or implicit. Now note, casting is done between two basic types. So we have what are basic types? We have int, byte, long, short, double, float. So we can do casting between those types. And we can also do casting between reference types or classes. When we talk about widening and narrowing casts, those are between our intrinsic types. When we talk about upcasting and downcasting, that's between our reference types. All right, you should be comfortable with that. So depending on the type that I'm converting from and to, then I may have to explicitly cast, which means I actually use parentheses in the type that I want to cast to, or implicitly, which means that I can simply try to assign a value of a certain type to a variable of another type, and that will be done automatically for me. With our basic types, so our intrinsic, our ints, float, long, double, short, if we are doing a widening cast, so we're going from one basic type, one intrinsic type, to another that can store more information than the first type, then we can do an implicit cast. We don't have to say that we're actually casting this from one type to another. So if you want to store an int in a byte variable, you don't have to explicitly say that I'm casting this to, sorry, from an int to a double. You don't have to explicitly say I'm casting it to a double, because everything that can be stored in int can be stored in a double. All right. Whereas if we're going the other way around, we're going to lose precision. We're going to lose everything after our decimal point. So if we're casting from a double to an int, we have to do an explicit cast. All right, we'd actually have to say whatever double we're trying to cast, before that we put our parentheses int, and that allows us to cast from a double to an int. We are losing some information. So we have some questions. What is the practical example where XOR operation is used for? Okay. Um, Now I can think of when we're using XOR gates to actually create our arithmetic circuitry within a computer, within ALU. But for a normal day-to-day application of an XOR, so you want to know if things belong to one group or another, but not both. So perhaps I want the list of first-year students, but I don't want those that are doing both computer science and informatics. I only want those who are doing either computer science alone or informatics alone. So I do an XOR on those two sets. That would give me only the students who are doing either computer science or informatics. That would tell me that they are actually extended program students, whereas those that are doing them both together are the regular program students. All right. So I don't want those ones who are in both, and XOR would give me only those that are in either one, but not both. Then that means double variable assigning an integer its implicit cast. Yes, if I have a double variable and I want to store an integer in that, I don't have to explicitly say that I'm changing that to a double. I can simply store that in there and it'll implicitly convert it to a double. All right. This is completely different from if I am working with reference types. With reference types, I can use implicit casts if I'm moving up in my hierarchy. So if I have a base type, I'm converting it to some ancestor of that type, then I can use an implicit cast. If I'm going from one type to a subtype, then I have to use an explicit cast. So let's say we have person, and a person can either be one of two subtypes, a lecturer or a student. Then both lecturer and students are people. So I can store a lecturer object in a person variable. It is a person because it's a subclass of that. I can use an implicit cast. But if I'm casting from a person to a lecturer, well, that person could be a lecturer or a student. I have explicit cast, and I may get an error if the underlying object was actually a student. All right, so the same types of casts, but they work differently when we're doing between intrinsic types or with reference types. The one has to do with widening and narrowing. The other has to do with upcasting and downcasting. All right, we'll stop there because our time is up, and we'll actually begin with examples of those two tomorrow. Um, and perhaps I'll give you a couple more hints on the practical assignment you're getting the next day as well. Are there any questions before we close up? All right, while you think about that and type that, I will say at the end of each slide or each lecture or each groups of slides within the lectures, there are some problems from the text that you are recommended to do. You won't get solutions for these, but these are tasks that you can do to ensure that you understand the work that has been covered. So that is one good way to prepare yourselves for the practicals each week. And there was a question about what type of student do you need to be for this module? Well, you have to do some self-study, not just for your mini project, but also because we are assuming that you understand Java, and you see we're covering it rather quickly. If you pick up in these slides as we're going through them, that there's some information that you don't know, that you have forgotten, you have to go back there and make sure that you relearn those things so that you're ready for the applications that we're going to do with those. All right, and that means doing the work that you're assigned, but doing a little more than that. So go ahead and do those tasks, and if you have issues, then come to a consultation, and we can assist you with that. There's a question, for those of us who don't have textbooks yet, can we get the questions as well? Yes, I don't think that's an issue. You're allowed to reproduce or publish small extracts from the textbook. So I'll put those, it's 2 pages for this first group of slides. I'll put those up. All right, and there's another question. Can you give one more hint on the practical? I will do that tomorrow. All right, so we'll end it there for those of you who have other classes.